Let's go back in time, about 2 billion years into the evolution of the Earth. This period was in some ways full of life, but it was marked by a great change. This was the time when microorganisms flourished, but also when one of the greatest diseases in history occurred. This unseen threat had a profound effect on the course of the Earth and set the stage for the modern world as we know it today. It changed the atmosphere, altered the ecosystem, and influenced the future development of life forms. The animals we see today, the food we eat, even the air we breathe, are all because of this revolutionary time. Imagine you are in a time machine and set to travel to Earth 2 billion years ago. You will land on an important moment in history. Earth is halfway through its current existence. As you get closer to the surface, you will see that this world looks very different from the Earth of today. Earth bubbles, early and ancient land masses melted and were separated by large oceans that may have been filled with ice. Many of these countries look a little like the countries we know, but then they start to change as they continue to be shaped by the powers that be. When your time machine lands, the environment you enter is an unsupportive and unstable land. It's a dark, rocky landscape with no sign of the lush vegetation or abundant wildlife that characterizes the new world. No trees, no plants, no hardy plants of any kind. You won't see animals here. Life at this time existed only in the primitive form microorganisms. This was a world before the emergence of multicellular life, most of which were simple organisms such as bacteria. As you stand in this ancient world, you may think that it seems calm and slow even by modern standards. But in some cases it's easy to be simple, at least there are no predators around. The lack of hard life means you don't have to worry about wearing it. However, before you get out of the time machine, put on a protective suit and an oxygen tank. Although there is oxygen in the atmosphere, it is not enough to breathe properly. Today's oxygen levels are less than 10%. Without protection, you won't last long in this environment. When the Earth first formed, the atmosphere was made up mostly of gases such as carbon, methane, and water vapor with little oxygen. Over time, the atmosphere changes due to the action of tiny organisms. When you get out, you notice that the water around you is calm, almost eerie. Don't expect to see familiar fish or aquatic life. Instead, the water is full of something even more ancient. Cyanobacteria, also known as blue-green algae. This slow green bacteria is one of the most important forms of life to have ever lived on Earth. Cyanobacteria are responsible for producing the oxygen we rely on to survive today. But they are also responsible for the world's greatest loss. To understand how this loss happened, we need to go back in time about 500 million years. By doing this jump a second time, you will find yourself in an unfamiliar land. This was a time when oxygen did not exist, and the Earth looked very different than it does now. The sun is darker and the young Earth looks colder, although it is still warm enough to hold water. Life in this era was limited to free-living organisms. Bacteria being the main form of life, cyanobacteria play an important role in creating the Earth's atmosphere. They developed the ability to independently harness the sun and use water to produce energy through photosynthesis, a process that released oxygen as a byproduct. As more cyanobacteria participate in photosynthesis, they begin pumping oxygen into the environment. At first, most of the oxygen they produced reacted with minerals in the ocean and crust, effectively removing it from the atmosphere. But over time, due to the growth and spread of cyanobacterial colonies, the amount of oxygen produced exceeded the ability of these natural processes to absorb. This oxygen began to accumulate in the atmosphere, marking a turning point in Earth's history. The Great Reconciliation. At first, the presence of oxygen in the atmosphere was not important. In fact, life has lasted thousands of years. But for other bacteria that thrive in anaerobic, unhealthy environments, this new development is dangerous. Oxygen, which is essential to most of the modern world, is toxic to these organisms. As the level of oxygen in the atmosphere increases, it becomes more difficult for these anaerobic organisms to survive. They began to die in droves, beginning what is known as the First Great Meeting. This disease killed 99% of all life on Earth at that time. But the effects of the Great Recovery Forum did not stop at the massive loss of anaerobic life. The sudden flow of oxygen had a profound effect on the world's climate. Oxygen replaced methane and carbon dioxide in the atmosphere. These gases created a greenhouse effect, keeping the Earth warm enough to support water and life. After removal, the planet cooled rapidly. Eventually, one of the first ice ages occurred, the Huronian Ice Age. Over the next hundreds of millions of years, the Earth's surface will change as ice spreads across the land and the oceans freeze. The Huronian Ice Age was a long and intense period of global cooling that covered much of the world in ice. During this time, the Earth went through 3 great ice ages, affecting not only the poles but also the land and even the sea level in some places. It's an icy and cold world with most of the planet's surface locked in ice caps. Life on Earth, which is plagued by high levels of corrosion, presents a greater challenge. The sugar freeze reduced the living environment that sustains life, but all is not lost. A small fraction of life, about 1% of the microorganisms that existed before the extinction, were able to adapt to the heat. These survivors, however microscopic and scattered, gave rise to the complex life forms that would one day inhabit Earth. As you continue, you will notice that the Earth is starting to warm again due to a combination of factors. Volcanism is one of the main causes of this warming. Although ice covers most of Earth's surface, the planet's interior is still warm and dense. Deeper in the surface, the heat of the Earth's melt drives tectonic forces. This tectonic activity caused massive volcanic eruptions that released large amounts of carbon dioxide and water vapor into the atmosphere. These gases become greenhouse gases, trapping heat and slowly melting the ice that covered the planet. In addition to the warming caused by volcanic activity, the sun also shines over time. The more sunlight, the more energy the sun exerts on the planet. This process, albeit slow, helped melt the ice sheets that ended the Huronian Age. As the ice retreated, the land changed again. Volcanic eruptions not only warmed the planet, but also helped shape the continents. The small peoples who lived at the beginning of Earth's history began to unite, eventually forming Nuna, the first great world. At the time of Nona's creation, the Earth was approaching the New Age, an age marked by the emergence of complex life forms. The atmosphere, now enriched with oxygen, is the basis for the development of new forms of life. Cyanobacteria, once the architects of oxygen production, had laid the groundwork for the rise of aerobic organisms, those that could use oxygen to fuel their metabolisms over the next few 100 million years. These microorganisms would give rise to more complex, multicellular life, setting the stage for the explosion of biodiversity that would eventually lead to the evolution of plants, animals, and ultimately humans. One of the most remarkable aspects of this period in Earth's history was the development of Earth's protective ozone layer. The oxygen produced by cyanobacteria not only fueled new forms of life but also formed a layer of ozone high in the atmosphere. This ozone layer provided crucial protection from the sun's harmful ultraviolet radiation, allowing life to thrive on land as well as in the oceans. With the ozone layer in place, Earth's surface became more hospitable to life, paving the way for the eventual colonization of land by plants and animals. As you stand on this ancient Earth, it's amazing to think about the incredible changes that have taken place over billions of years. From a planet dominated by microorganisms to one teeming with life in all its forms, the story of Earth's evolution is a testament to the power of life to adapt, survive, and thrive. And even as you return to the present day, the legacy of these early events continues to shape the world we live in today. The oxygen we breathe, the continents we walk on, and the ecosystems that sustain us all have their roots in the distant past, in a world once dominated by cyanobacteria and shaped by volcanic eruptions, ice ages, and the forces of evolution.